guys, thanks for watching. Today we're going to be talking about laws of exponents, and once we learn the law of the exponents, so all the laws of the exponents, we're going to do lots of simplification. And that's really what we're aiming towards, is simplifying complex rational expressions. So I want to talk about the 9 laws. We're really not going to be talking about the 9th law that much. I really want to focus on the first 8, so I'm just going to go through them very quickly. They're pretty self-explanatory. X, your base. Anything raised to the 0 power is going to equal 1. So 3 to the 0, 100 to the 0, that's always going to be 1. Anything raised to the first power, anything raised to the first power is always going to be itself. Okay, so oops, that's a mistake. Anything raised to the first power is always itself. And then once you start multiplying, dividing, fractions, all of that's where it gets fun. So if they have the same base and they're being multiplied with different exponents, you just add the exponents. Okay. Same base, so this is law number 4. Same base, except it's in the form of a fraction. It would be subtracting the exponents. And we're going to practice all of these in the 3 examples I have. Rule number 5, one base with an exponent attached to it and then another exponent on the outside of the parentheses. What you do there is you multiply the exponents. Rule number 6. Rule number 6 is kind of like a distribution rule. So is number 7. If you have one exponent attached to multiple bases, then you kind of like distribute that exponent. And then same thing for rule number 7. Even if it's in the form of a fraction, you're still going to like distribute that exponent by multiplying. Okay, we're going to practice that a lot. Here, this is a very, very handy rule. If you have a negative exponent, you can turn it into, you can get rid of that negative because we never want to deal with negative exponents. We can just turn it into a fraction, stick it on the bottom, and then that exponent becomes positive. Also, if you ever want, a positive exponent, you just flip that fraction, and then that exponent becomes positive. And so I'm going to show you how to do that also. And then last but not least is rule number 9, which we're not going to be using today, but it is good to know. So I'm going to try and keep it under 15 minutes. So let's just jump right into it. I have 3 examples, and I'm going to go ahead and solve or simplify them. So when I say simplify, I mean make it as nice as possible, as clear as possible, with no negative exponents. Okay, if we can get rid of the fact that it's a fraction, even better. But the most important thing, no negative exponents. Okay, so say I want to simplify this expression, m raised to the negative 2 times n raised to the negative 10 over m raised to the negative 7 times n raised to the negative 3. Lots of negatives. I want to get rid of all of them, and this is how we're going to do it. So I'm just going to rewrite the problem. I'll do it in red. So m to the negative 2, n to the negative 10 over m to the negative 7, n to the negative 3. There's a few ways to do, there's no just one way to solve these problems. There are multiple ways to do this, and the one on the back. So I'm just going to show you my preferred method, but feel free to email me with screenshots of what you think is another correct method. So I personally want to just eliminate all negative exponents first. So what I'm going to do is I'm just going to flip the positions. Okay, so m to the negative 2 would become, for example, This is my fraction, and I'm going to flip everything around. So then this would be m2 and 10. So that eliminates the negative exponents, but the number stays the same, and the base stays the same. And then I'm going to put these on top. M7 and 3. So automatically it looks a lot nicer. So now we're going to keep going. Now we're going to use rule number 4. Okay? So same bases, except the exponents are different. So this becomes m7 minus 2 n, just right next to each other, and 3 minus 10. It is very important that you keep the number on top first. Very, very important. If you mess that up, you are doing it completely wrong. So very important, the number on top comes first, then you subtract. If this number is a negative, you do not drop that negative. You keep it right there. And I have examples that cover that also. So now I'm just going to subtract. So now that becomes m5 and negative 7. Negative 7. So negative came back to haunt us. What we're going to do, turn it into a fraction. Stick that entire piece on the denominator of that fraction. So your final answer becomes m to the 5 over n to the 7. Okay? Okay, so, sorry, I'm just checking my timer. So that's how you solve the first one. So we're going to move on to the second one. So it looks a lot uglier. 2p to the second, and that is all raised to the negative 3. Q raised to the 4 all over 6q raised to the negative 1, p to the negative 7. First thing first, we're going to try and get rid of these parentheses negatives. I like to do that first. And then we can talk about distributing and subtracting and adding and all that stuff. So 2p squared to the negative 3, and then q to the 4, all over 6q to the negative 1, p to the negative 7. So I'm just going to take this entire term, and I'm just going to stick it on the bottom. And then I'm going to, so again, I'm like flipping spots. So that'd be 2, oh, I'm sorry. That would be, so that's Q4 on the top. That stays exactly where it is. I'm going to move the P upstairs to get rid of that negative. Okay, so I've got rid of that. I've got rid of that. This originally downstairs, I'm going to move upstairs. 6q to the 1. And then, so I've got rid of that. So this originally upstairs is now going to go downstairs. So 2p squared raised to the 3rd. So it looks a little nicer now. And so now what we're going to do, we're going to distribute using this rule, rule number 5. So Q4, P7 stays exactly the same. 6 to the 1, Q to the 1, otherwise known as 6Q. Okay, we haven't simplified yet. We're still getting rid of parentheses and negative exponents. So now we're going to distribute. So that's 2 to the 3, and then P 2 times 3. Okay, so that becomes up here. So that's 6Q. So the Q to the first power, 6Q to the 1, Q to the 4. So that becomes 6Q to the 5 because I'm adding, but my coefficient stays the same. P to the 7 over 2 to the 3rd is 8. 8, and then P raised to the 6. Okay, almost done. So now we're just going to simplify the exponents and the coefficients. So 6 divided by 8, that you can pull out a 2 or you can divide by 2. That leaves you with 3 over 4. 3 over 4, just like that. And now we're going to do the variables and the exponents. Q is all by itself, so we're just going to keep it right where it's at. P, there's a P on the top and a P on the bottom. So what we're going to do is use the quotient, like the quotient rule. We're just going to subtract. So P, it's P7 minus 6, which is P to the 1, which is just P. So I'm going to, and since it's a positive P, I'm going to stick it right on top. So this is my final answer. Okay? So now we're just going to do, and you can go ahead and pause it right now if you want to. But we're going to go ahead and solve the last one on the back. Okay. So I'm utilizing every single law. Okay, and I think this example will really drive it home. I'm going to use black. Okay, so it's first things first, it's a negative exponent attached to everything. So what I'm going to do to get rid of that negative exponent is flip the entire fraction. Okay, so everything that's downstairs is going to go upstairs. So that becomes x to the 8, z to the 6, y to the 4, over, and notice, I'm not changing the exponents. I'm just flipping it, okay? And this is going to alter this only. I just want to get rid of that negative. And so this becomes, so this is just going downstairs. Okay. Raised to the positive 4. Raised to the positive 4. If you want to go ahead and put them in alphabetical order, let's go ahead and do that. So we'll just make it nice and easy. X, y is 4, z is 6, and then x is negative 3, y is negative 1, z is 2, all raised to the positive 4. What I like to do now is I just want to get rid of this parentheses and this exponent. And so we're going to distribute. We're going to distribute that exponent because it's attached to every single thing inside the parentheses. So this is what it's going to look like. X negative 8 times 4. Y 4 times 4. Z 6 times 4. Over x negative 3 times 4. Y negative 1 times 4. And then z. And you can leave a lot of room, which is what I recommend. Z is 2 times 4. Now the parentheses and the exponent is gone. Okay, so now we're just going to start multiplying. That's negative 32. That's y 16. That's z 24. Over x negative 12. Negative 4. Z 8. Okay, so what we're going to do now is we're going to start subtracting. So this is what it's going to look like. So you keep all your bases with each other. Your x's with your x's, y's with your y's, and z's with your z's. So x, it says negative 32 minus, because of the fraction, minus negative 12. Y, 16 minus 4. Minus negative 4. Sorry, that's my timer. equals, and then z, 24 minus 8. So notice there are a couple in here where you have two negatives sitting right next to each other. So this is where it becomes one fat positive. Okay. Plus. So negative 32 plus 12 is x to the negative 20. Y 16 plus 4 is y to the positive 20. And then z is 24 minus 8, z to the 16. So I'm just going to put them right next to each other, which I can do that now because when you subtract, you eliminate that fraction. Okay, so that is x negative 20, y positive 20, and then z 16. Last step is to get rid of a negative. And so the only way, like the easiest way, the fastest way, the most fun way in my opinion, is to get rid of a negative is just put it downstairs. Okay, so it becomes y20 z16 over x20. And that's your answer. That's as simple as it's gonna get. You can't really mix exponents when you have different bases and x, y, and z. So from here all the way to here, you can see the appeal of this. I would much rather look at this than deal with something hideous like that. And so these three examples cover the most difficult questions on the PDF that I sent you. If you can understand example 3, if you just all you have to do is like pause, every once in a while to like let it soak, then you're gonna be fine on the PDF. But yeah, so thank you for watching. I hope this kind of cleared it up a little bit. Sorry. But continue to email me, like, comment, subscribe. Yeah, I hope it helped. And thanks for watching again. Bye.